great enemies which threaten humanity: fever, famine, and war. Out of these three, the worst by far is fever. The one from the swamps, malaria, which is also referred to as paludism. It is caused by a tiny parasite carried by mosquitoes. When it comes into contact with populations living in intertropical zones, this parasite becomes a weapon of mass destruction, attacking 750 million victims a year. More than 3 million are killed by it, especially children. 90% of these victims are found in Africa, where malaria has caused more deaths than AIDS. Not being a disease covered by the media, until very recently the ravages to humanity caused by malaria have been treated with indifference by industrialized nations. And then people began to wonder, what if global warming would make this random killer of 2 billion people, a third of humanity, reappear in temperate zones? " 106 countries out of 180 are affected by this plague. For several years, due to the pressure of diverse international organizations, the pharmaceutical industry has started to take action, and research centers have intensified their work. This is the case of the Institute of Research for Development near Montpellier in the south of France. Here, more than elsewhere, malaria continued to be prevalent until the middle of the 20th century. It is an area of marshland where the mosquito larvae have been eradicated thanks to insecticides.
It is a mistake to forget malaria in Europe because it was an endemic illness from Scandinavia to the south of Europe, in particular in France, Germany, the Rhine Valley, the Camargue, around Paris and so on. So we have rather forgotten what malaria is, considering it now as a tropical illness, whereas it was a killer in our own latitudes.
And it's coming back. Half a century ago, the World Health Organization thought it had wiped out malaria. Unfortunately, it was a failure. The disease has once again attacked vast regions from where it had completely disappeared.
Why is malaria now coming back to Europe? Of course, it has not reached the epidemic or pandemic levels that one finds in Africa. However, we can put forward several hypotheses for this increase in malaria in the east of Europe. It is a situation made up of different factors: human factors, the changes in human behaviour, environmental factors, modification of the environment, and of course climatic factors, global warming, modification of the cycle of rain. In some countries it is the environmental factors that are the most important, in others it is more related to the behaviour of man.
This is the case of Turkey, which has mobilized the biological laboratories at the University of Ankara to fight the problem.
Malaria, is a very important disease in everywhere, but in Turkey it's most important. 150,000 malaria cases. And then, by the help of World Health Organization, very successful malaria control programs began in Turkey. And after those times, the malaria cases decreases gradually.
To develop, the paludism parasite needs both men and mosquitoes. Without both, the disease cannot exist. This interaction is being closely observed in Anatolia, a region that possesses all of the right conditions for malaria to break out once more.
We are in the very important part of the triangle, part of leg of the triangle. This is the triangle, this is human source and vector and breeding places. This one is part of this triangle. That's why there are many people from the southeastern Anatolia for working on the rice fields. And then after the breeding, after the pupa, and adults fly away to there and buy the source from the southeastern Anatolia, and then maybe in the future, and the epidemic is growing up over there.
An infected human coming from a malaria-infected zone can contaminate a healthy mosquito. However, only certain mosquitoes are able to harbor the parasite of paludism. That is why it is indispensable to identify the species of mosquitoes that reproduce in the rest of the country.
Actually, there is endemic malaria in Turkey because Turkey is the only country in temperate zone on the edge of the European country. But the threat is so slight actually because the malaria cases are restricted in some places and tourists don't go there.
Tourists and businessmen travel more and more all over the world. Pharmaceutical laboratories have provided them with more or less efficient anti-malarial medicines. In spite of this, every year nearly 20,000 people come back to Europe with malaria. The lack of information has caused more than 100 of these people to die from the disease. Nevertheless, malaria is not a new infection like the avian flu or mad cow disease. This deadly fever has been known since the most ancient times. Malaria has wiped out entire armies, killing en route some historical characters such as Alexander the Great. From the 2nd century BC, the Chinese found a way to cure the disease with endemic plants. Later on, Inca shaman discovered the perfect answer, the bark of the cinchona tree. Stolen from the Indians, this discovery allowed the Spanish conquistadors to conquer part of the New World. The Jesuit missionaries understood the usefulness of this plant and had it brought to Europe, where malaria had been cruelly rampant. It was the main cause of mortality among the workers who built the royal castle in the swamps of Versailles. In Africa, it is called the white man's disease. On average, the latter do not survive more than 45 days. In the conflicts in Southeast Asia, malaria caused considerable ravages among the American troops. To defeat the enemy, the US Army decided on the biggest tests of medicine ever undertaken. Malaria had better watch out. Unfortunately, the treatments that resulted from this research have been little used in the Southern Hemisphere. Since then, pharmaceutical laboratories have invested in more profitable diseases. In Africa, they have had to learn how to cope with malaria by themselves. Children are the primary victims. It all begins like a simple case of flu. A coma can develop 3 days later. Following this, a prognosis depends on how fast competent care can be attained.
Did he vomit? How many times did he vomit? He vomited twice? Let's see how you are getting on. You're not as dynamic as you were. You're a bit knocked out. You don't play anymore. We can see that there is tachycardia. The temperature is now 38.6 degrees, 38.7. So we're going to send it to the laboratory for a more detailed analysis. There is a chance that it is malaria.
From time to time, in some remote regions, a small laboratory can determine if the parasite is present in the blood.
My wife has had 10 pregnancies, but I only have 5 children. According to the tests, all my children had malaria. The first one died just after the baptism, the second before baptism. The third one survived a few years. He had fits because he was epileptic, and the last 2 also died. Out of 10 children, I lost 5.
Pregnant women are also prime targets for the disease. They often arrive for consultation too late. Here, work in the fields takes priority and leaves them with little time to look after their health.
When a woman has her first pregnancy, it's like it's virgin territory. There are no anticorps, nothing. The parasite has all the time it wants to settle in because the placenta is considered as the ecological home of the parasite, the implantation of the parasite at the level of the placenta. This is what makes malaria a very serious problem for this pregnant woman. The newborn baby as well. There are all these consequences that follow on. One can have allergies, a low birth weight, and a child that weighs 800 milligrams, for example, doesn't have the same chance as the one who weighs 2 kilograms. So there's all this anemia, a high mortality rate.
The principal factor, malaria in Africa, develops in small areas of water collection, most of the time dug around the villages. Most of the houses in the villages are made of brick. To make these earth bricks, pockets of earth are dug around the villages. Houses are built, ditches and ponds remain around the village. Mosquitoes come and lay their eggs in these ponds. And when the mosquito needs its meal of blood, it only has to go 50 metres. It reaches the houses, where man has dug his own grave, as he has created a habitat for the mosquitoes and the food for the mosquitoes at the same time.
Studies have proved that there is a high risk in living near a calm and clear body of water. Carrier mosquitoes of paludism don't like pollution. Good news for northern countries. In order to wipe out malaria, Western laboratories have found themselves confronted with a large-scale problem. Over several decades, parasites and mosquitoes have found every means imaginable to adapt to all the available modern treatments employed to fight them.
I would say that we have fewer means available to control malaria than we have ever had. There was an optimum moment coming from organic chemistry with the advent of organic chlorinated insecticides like DDT, an anti-malarial synthetic medicine called chloroquine, nivoquine, which treated all cases of malaria completely. The extensive use of these products principally allowed mosquitoes to develop a resistance to DDT. We have medicines that we have used up, one after the other, and we are finally left with two that were invented by medicine men in South America and eastern China. In other words, natural quinine and artemisinin derived from a Chinese plant.
Since this time, research has been at a standstill and has taken off in every direction. It is true that the opponent is not an easy one to fight. The parasite can change its form 7 times as it propagates from mosquito to man. When an infected female mosquito bites a human, its salivary glands transmit the parasite to him. It is involuntary. The real objective of the insect is to extract blood to nourish its eggs. Once it's in the human organism, the parasites seek refuge in the liver in less than 20 minutes. In this way, they avoid an encounter with the immune system, which could easily eliminate their small number. Each parasite penetrates into the interior of a hepatic cell. Once there, it actively divides to give birth in several days to some 10,000 new parasites. The cell in the liver bursts and liberates the latter into the bloodstream. At this stage, the parasite uses camouflage to confuse the defense mechanisms once again. The invasion of the red blood corpuscles can begin. The parasite transforms itself again and by cellular division produces 10 others, which makes each red blood corpuscle explode, allowing them to contaminate other cells in the vicinity. This is the period when the infected person suffers the most. During each cycle, the sexed parasites, male and female, form and invade the sick person's blood vessels. When another uninfected mosquito comes for its meal of blood, it ingests these sexed parasites that then meet in the digestive tube. Their insemination produces an egg that develops and ends up migrating across the digestive tube wall. Small parasites are born and arrive at the salivary glands of the mosquito. The circle is completed. When it has another meal of blood, the mosquito will contaminate another human.
In the entire world, 3,500 different species of mosquitoes have been identified. These 3,500 species are vectors for different diseases and malaria. The paludism parasite, which is a plasmodium, is transmitted by mosquitoes called Anopheles. That are capable of transmitting paludism and plasmodium parasites. Among these 60, there are roughly 15 present in Africa. What we are primarily trying to do is study their biology in order to better understand where they're found, how they bite, why they bite, and with this basic information to develop and improve our battle strategies in the field.
These strategies have been studied in several African countries, especially in Cameroon.
It's a particularity of Cameroon that in the forest areas we have a large number of mosquito species that can transmit malaria, and all of these species have totally different biologies. So we cannot allow ourselves to think that we are just fighting a single enemy.
The first enemy is the killer mosquito, and once more it has to be identified. That is why the IRD teams go into homes to collect different species that cohabit with man. Cameroon covers a huge land area that extends from the Sahel Desert to the heart of the equatorial forest. The populations of mosquitoes there are as varied as the human ones. They have evolved together since the invention of agriculture. Here, in the proximity of Yaoundé, it is the Anopheles gambier that reigns over all the others. This mosquito is the principal vector of the most dangerous parasites to man. One of the aspects of the research is to understand why these species prefer to bite human beings rather than animals.
The study of the characteristics of mosquitoes will permit us to really identify which species are important in terms of transmission in order to identify the signs, actions and means of control. All these species have different ways of behaving. They won't reproduce in the same types of larva shelter. For example, some species will have a tendency to bite indoors, others more outdoors. The same means of control won't be efficient in the same way against different species.
Here, everything contributes to the development of the Anopheles, the high-risk mosquito.
It is really exceptional because we have 5 species here along the edge of the stream, and they're present practically all year round. We have the Anopheles gambii, which principally develop during the rainy season, when there are ponds around the roads, villages, so it's a zone that has a really large concentration of malaria. An inhabitant suffers 1 infected bite per day on average, which means that the area is highly malarial. There are hundreds and hundreds of cases of malaria throughout the year in this region.
Certain species of mosquitoes can live for almost a month. This makes them dangerous. In fact, if an impregnated female bites a contaminated man, she can transmit the disease up to 12 days later. As she gorges herself on blood between each laying to nourish her eggs, she can infect new human beings up to the time of her death. During this time, in the water, the eggs transform into larvae, then into nymphs, and finally into weapons that only need to be loaded with deadly parasites. Only the Anopheles gambier can be bred in an insectarium. The other species die as soon as they are no longer in nature. In Yaoundé, larvae and nymphs of these mosquitoes are put into cultures. Once they are adults, you are sent to London, to one of the greatest European laboratories of molecular biology. Recent sequencing of the genome of this mosquito, and even more recently the genome of a parasite, have opened new perspectives in the fight against malaria. As a new way to attempt to block the transmission of infection between the mosquito and man. The technological platform in London is developing experimental models with an aim to make the mosquitoes resistant to parasites.
So in our laboratory, we are studying the interaction between mosquitoes and the malaria parasite. We're interested in what's happening inside the mosquito. So we are studying the immune system of the mosquitoes mainly. We are modifying the system of the mosquito to see whether the parasites can be killed. We identify genes of the mosquito that may affect the parasite in natural malaria transmission conditions. Once we identify this gene in the mosquito, we can manipulate the gene, and then we study what happens inside the mosquito.
This is not an easy job to do. 14,000 genes have already been identified. To make it harder, the laboratory experiments that test the resistance of the mosquitoes are not done with the difficult-to-preserve human parasites, but with those of mice.
So we collaborate with a unit in the IRD in Montpellier and that have an outstation in Cameroon. And we're trying to transfer the technologies and the knowledge we have developed all these years in the laboratory to transfer them to the field.
To study the development of the human parasite in the mosquito, Cameroonian teams must begin by infecting their laboratory mosquitoes with contaminated blood. To find contaminated blood, one just has to look for it where it is, in the schools in the south of the country. In these zones of permanent transmission, children can be infected through bites as many as 1,000 times a year. This means that here at Mfu, when a child does not die from malaria, it is highly possible that he will be a carrier of the sexed form of the parasite, the gametocyte. These gametocytes, the mosquito's infectious agents of the disease, are what the doctors are searching for. Small blood samples, called thick blood smears, will make it possible to check if the child's immune system has started to eliminate the parasite. The analysis of these thick smears has been carried out in the IRD laboratory. It requires very experienced technicians to discover the gametocytes in the blood and to determine the quantity of the parasite in each child. The least infected children are treated directly in the hospital, whereas those who are severely ill will have a small quantity of blood taken from them by the IRD doctors, in addition to the required treatments. This blood, treated with non-immunized European plasma, can be used to infect Anopheles. It is an ingenious system in which water flows at 37 degrees to keep the human blood tasty for the females. The latter feed themselves through artificial membranes. For some of these, this will be their last meal. 7 days later, these Anopheles are going to be studied under biologists' microscopes. An extremely delicate intervention is then carried out.
These are the mosquitoes that have just been infected by the parasite, and I dissect the stomachs to analyze the genes that react to the infection. The idea is to understand the mosquito's mechanisms of defense against the parasite in order to eventually help the mosquito to defend itself. So if the mosquito isn't infected anymore, it won't infect man.
A second batch of infected females is anesthetized by hypothermia. They receive a dose of ARN, which will modify the activity of the protector genes of the human parasite. In the long term, amongst the other roads of genetic research, The idea would be to produce a transgenic mosquito that is livable with. Could it replace all the dangerous species one day?
The development of genetically modified mosquitoes, which are incapable of transmitting parasites, is one of the fundamental types of research being carried out currently. We are very far from applying this in the field, but nevertheless, these genetically modified mosquitoes are marvellous laboratory tools that enable us to understand how a mosquito is able to resist a parasite.
At the Pasteur Institute in Paris, researchers are working on a second major path of research, vaccines. However, to come up with one quickly to stop malaria seems just as unlikely as one to stop AIDS.
The parasite is 500 times more complex than a virus. There are about 5,000 proteins in a plasmodium, about 10 proteins in a virus. If we take as an optimistic hypothesis that it takes 10 years to make a vaccine against the AIDS virus, by applying the same strategy, it would take 5,000 years to make a vaccine against malaria. Since the malariologists are about 1,000 times less numerous than the AIDS scientists, it would take about 5 million years. And in 10 years, we haven't come up with a vaccine against AIDS.
It must be said that vaccine research has run up against a sizable obstacle, the difficulty to work on human experimental models. So the researchers in northern countries have to use laboratory mice to test their vaccine prototypes. There is a type of chimpanzee malaria that resembles human malaria. However, scientists do not allow themselves to work on these models as they are much more precious than simple rodents.
When we look at the characteristics of infection, because we look at the rodents on which vaccines are made and those that are found in man, the characteristics of infection and resistance are exactly the opposite. That is to say that with an animal we have parasites that increase rapidly and that generally result in total mortality. In man, we have an infection that's chronic, a high mortality rate, but is low in relation to the number of carriers. In fact, luckily, 99% of humans survive. The mortality rate is the opposite of that of animals. After a human is infected, he would treat it to keep him from dying, while an animal will build up a resistance to any further infections. It will acquire total protection. Man has to be infected 10, 20, 30, 40 or 50 times in order to acquire that same protection. So to imagine, with such different schemas, that we can develop within these models efficient ways of fighting in this situation is, in my opinion, an aberration.
Despite this, research is being carried out on two groups of vaccines, those destined for northern populations to prevent them from contracting the disease, and those destined for the southern populations that are already living with the disease. At the Pasteur Institute, Pierre Druil's team has developed a vaccine for the second group, which is still waiting authorization to be tested in the field.
In contrast to AIDS, people who are exposed to malaria build up a resistance. So what we have done, from a medical research point of view, is to study some discriminatory clinical situations in which we have groups of subjects, some of whom are protected and others that aren't protected, and to look at what makes the difference. That is to say, do research that is not focalised on the protected component, to see what systems man develops to protect himself. For example, we have passively transferred immunoglobulins, that is to say, taken antibodies from an African adult subject who has acquired protection and give them to some Thai children who have not been protected. From this we have found a defence mechanism.
These antibodies were transferred to some sick children who had been hospitalized, and we observed that effectively it worked against the parasite and these children were cured. There we were sure that there was something in the serum, in these antibodies, that had an anti-parasitical effect.
So we think that our approach is valuable, as it has allowed us to find things that no experimental model has been able to reveal.
To apply the laboratory models, it is necessary to work in partnership with the structures in southern countries. In Africa, they are often much more advanced than one could imagine. Situated just 2 steps from the equator, On the principal Gabonais River, the legendary Albert Schweitzer Hospital has become the advanced outpost for applied research. A foundation has been created, and with numerous subventions, as many European as American, it has become a pole of excellence. Western research is often cut off from reality. Here in Lambaréné, scientists are in direct contact with the sick. The center of research and the hospital are one and the same.
Our specialities in Lambaréné, in the Albert Schweitzer Hospital, are, in priority, therapy and prophylaxis. We also carry out research and test antipolludal vaccines.
The local teams of Pan-African origin work alongside the German University of Tübingen.
The microbe, which is responsible for malaria, is very variable. It makes it very difficult to know completely its characteristics and to be able to isolate a part that could produce an efficient vaccine. So if we rely on our scientific convictions, purely scientific, we have a right to be pessimistic. However, there has been some progress that has been made, and some parts of the parasite have been identified, and we are able to use them as sources for vaccinations. We are working on a vaccine called RTSS that is being developed in the field. That is to say, the first effects of the vaccine and its innocuousness are being studied. However, we will have to wait until the end of the final test that will begin in the middle of next year and which will last 2 years in order to have an idea of its effectiveness. Currently, it seems that this vaccine, RTSS, will only have a 30% effect over a rather short period of time.
There are other vaccines against malaria that are being developed. For 15 years, public pronouncements lead one to believe that the vaccines will soon be ready, yet the dates are always pushed back. In the meantime, it seems that the RTSS vaccine is, if not the most promising, by far the best financed.
Do you know how to do it like that?
A large part of the program is taken in charge by the Bill and Melinda Gates Foundation.
We are here to work with the Clinical Research Center at the Hospital Albert Schweitzer for the RTSS program. We are conducting trials in phase 2 and preparing for a phase 3 study of the RTSS vaccine candidate. We really haven't done that before, so it's the first time, and that's exciting. It's possible because of the foundation that we could get to this point. Hopefully to a successful result, to a malaria vaccine that we can give to children in Africa. You know, that's what we hope for.
It is very important to keep in touch with the patients and reality. The higher up we climb in the hierarchy, I'm a teacher myself, the more time we spend on the telephone and in front of the computer. It is at this stage that it becomes essential to go back to the sick, to make contacts again in the field, and to live daily with malaria, even if it is only a few hours in the week. We have come into the village to carry out a post-examination in the framework of a study of chemotherapy against malaria. It is a large program that concerns 1,200 children, and we examine those who have received a placebo, in contrast to those who have been administered a real therapy. The results show that it has an excellent effect on the anemia, which weakens the children stricken with malaria. It is said that research in Africa is an applied research, and that applied research really allows us to have immediate results in the field. And that is what makes our African researchers feel optimistic.
Research in the north has advanced, but much too slowly in regard to the destruction caused by the disease in the underdeveloped countries. Malaria is not only a consequence of poverty, it is also the cause of this poverty. Hence, while waiting for a vaccine, Africa has stepped up the transmission of information on prevention among the populations at risk. It is the third strategy of the battle.
In his mother's womb, the virus passes through the umbilical cord. It's often the first visit when women have not yet received treatment that we see some cases here. For example, that one here. It's her first visit in consultation today, and the thick blood smear is positive, so we are going to treat her. Here you take those 3 pills there, over there. Since people now have access to treatment, there have been fewer and fewer cases of malaria in expectant mothers. In relation to previous years, it's diminished.
The best protection would be to eradicate the mosquitoes. Unfortunately, the appearance of resistance to insecticides and the principles of precaution in the north have deprived the south of an efficient weapon, DDT. Researchers are currently working on products that are likely to be as efficient. Insecticide combinations have been tested on mosquitoes to evaluate their resistance mechanisms. All this in order to maintain the efficiency of the only protection tool available, impregnated mosquito nets.
It's important to know that there isn't a single insecticide that has been developed specially for public health. Insecticides that are used for household spraying or for impregnating mosquito nets, for example, are all derivatives of those produced for agriculture. The only insecticides used for impregnating mosquito nets are pyrethroids, which are not very toxic to man and have an effect called knockdown. That is to say, they kill the mosquito before it can bite someone.
Look above the shelves. With the mosquito nets, there are no more malaria. In this way, the children are protected by the mosquito nets. Mosquito nets were recently distributed by the Minister of Health, an impregnated mosquito net. I am starting to sleep peacefully with my baby.
There is a real scientific, epidemiological and almost ethical question that is posed concerning the use of mosquito nets. In zones where the population is very dense, use of impregnated mosquito nets is going to decrease transmission. However, by decreasing transmission, at the same time, we are also diminishing immunity acquisition.
In fact, by avoiding infecting bites, a young child risks developing a weaker immunity. It is possible that he will be weakened when he reaches adulthood. However, this is only a supposition. In doubt, it would be better to save him while there is still time.
The government has given us mosquito nets to tell us that malaria, AIDS kill. However, malaria, it kills every day. Mothers, oye! Here's the mosquito. It's very small, but the mosquito kills us every day. It kills our children and also adults. Mummy was bitten by a mosquito. Mummy is sick. In a house, when we think about the king, the queen of the house, we always think about the mummy. It's the mummy who keeps the house. If mummy is sick, there isn't any joy. Even if Papa is there, it's mummy who gives the orders. The mothers, oye. Who can read that? To be able to kill the mosquito, we must know their habits. Up to now, we know where the mosquitoes live. The mosquitoes live in puddles of water. There around our houses, there are a lot of them, thousands. He is going to be bitten by 100 mosquitoes. The little sister is going to die of malaria fever. It's not a lie. A little bit of negligence. The little sister is going to find herself in the cemetery. The little sister is dead. The mothers, oye. The little sister is going to die. She is already buried. The mothers, oye. Here we are. We can see here the child under the mosquito net. But the mummy has improved her ideas. She has understood. She has been sensibilized. She has been touched. She's gone off to improve her child's situation. It's like this that we must do it. It's a pity. No one's listening.
The systematic informing of populations is the first step. Yet the place where malaria is best dealt with is in Mali, one of the poorest countries in the world.
This is what I call good individual medical practice, which necessitates accessibility and good public health practices. Public health aims at the whole part of the population that is dying from the disease.
Under the aegis of Professor Ogobara Dombo, an eminent personality renowned in the international scientific community, the University of Bamako is endowed with an extremely efficient center of malarial studies. "30 Malian researchers, trained in Bamako and having obtained high-level skills abroad, have come back to Mali to participate in a national effort to eradicate malaria."
The parasite has one characteristic. That is to say, the species that kills, the species that is prevalent in 90% of Mali, which is called the Plasmodium falciparum. It attacks the brain rather rapidly, that is to say, after a certain number of reproductions in the blood. Its speciality is that it infects our vital organs. So you can understand why the development of a parasite in a child's brain could create permanent lesions that could lead to a coma and death. And it is these social outcasts, from an intellectually creative point of view, who constitute a burden that hasn't yet been calculated in Africa and who motivate our engagement in other fields of research.
Malaria has certainly increased the gap existing between the north and the south. Here in Mali, Professor Dumbo has put into application a daily battle plan that is imprinted with a very African wisdom.
A child who has reached the age of 5, who hasn't died from malaria, or who hasn't been damaged by it, is in a state of premonition that allows him to make a pact with the plasmodium that is in a pre-armed state. He says, "I know you, you know me. Each of us needs each other. We won't hurt each other." So, as long as it can operate like this, he can move on towards adulthood, and he can continue to live even with the disease. It's a permanent negotiation.
This permanent negotiation must also be adapted to the climatic conditions. In humid equatorial countries, malaria is present all year round. Children are infected several times a day. They develop their immunity at a very young age. In the south of Mali, near the Niger River, transmission lasts about 6 months. Children are less protected and can develop serious forms up to the age of 10. In the north, in the Sahelian zone, the period is very short. Children do not develop immunity. as adults they still die from the disease. This complexity is aggravated even more by their way of life.
The economic conditions in which these populations live have to improve, and their type of habitation has to improve as well. And so it's whole, not only scientific, not only sanitary. It's a whole that consists of the environment, development and changes in mentality that will all contribute to making malaria decline.
This village, near Sikasso in the south of Mali, is perhaps the one where malaria has hit the hardest. It is being currently used as a test village. Here is where Professor Jimbi, assistant to Ogobara Dumbo, supervises the test of a medicine that has been talked about a lot, the Azac. It is not a miracle remedy, but a complex association of two former medicines that, when taken separately, had lost some of their efficiency. The pharmaceutical firms, having abandoned their patents, made it possible to treat simple forms of malaria for less than $1 per person. It is not very much, but in some African states it is a lot.
Since 2001, we have carried out studies to evaluate the efficiency of medicines that have been used against malaria. And these results have been used and have served to demonstrate the lessening efficiency of monotherapies. And through this, our country has decided to advocate policies to use therapeutic combinations. These studies have not only demonstrated their efficiency, but also the harmlessness of these therapeutic combinations. And each year, at the end of the season, we organise a meeting to return the results of the research to the community. I'm very proud to be the test village for this innovation, that they will always be near us and help us so that we can fight this disease together.
In Africa, applied research used rationally has started to produce visible results. It is not by trying to improve candles that electricity was invented. While in Mali, researchers are using all their means to fight against the disease. Intermittent preventive treatments, taking care of the sick early on by using therapeutic combinations, and providing impregnated mosquito nets. Professor Dumbo's team are also testing a vaccine that is already being tested in clinics. Mothers and children are vaccinated in some of the health centers and then followed for more than a year. Of course, the financial means come from Western countries, but the skills are local ones.
It's a vaccine that's aimed at the phase and the parasitization, when the parasite reaches the blood. Whereas the other vaccines that they are developing in collaboration with the American Army has the objective to prevent malaria before the parasite reaches the blood. In other words, still at the level of the liver.
So it's for people who have not had malaria yet. Whereas the vaccine tested in Mali is for the populations already stricken by the disease. The greatest difficulty consists in making the villagers understand that their blood will not be sold. Some laboratories have already done much worse.
They're from the community, so we explain the objectives very carefully to them, and so on. They serve as a bridge between the community and us. These people know each person's house, and so they go from house to house for the children who don't come, and call them, make them come back to the centre. So it is very important to involve the community itself when you go to carry out clinical tests in an environment of this type. My collaboration as a traditional medicine man comes from the fact that I'm from the village. I'm the son of a traditional medicine man, so I know their social weight. They are the first contacts with the sick people. We can't forget that, and they're the people who have influence in this population that doctors like me don't have. We told ourselves that if we work with them, we would be able to improve the treatment of the sick that we pass on to them. Nowadays, the traditional medicine men bring us into the 6 manifestation clinics for children, and we can make a diagnosis very rapidly so they can be looked after properly. When a child comes and he sees that he cannot treat him, he sends him to the centre. If he can treat, he'll treat. And he says that since he began, no child has died in his home. For example, in this village of 8,000 inhabitants, from 140 to 160 are expected to die each year from malaria. With our presence here, we reduce this number to 1 or 2 per year, and this is to tell you that it's truly an enormous success and that this model could be repeated everywhere. The fact that there are 20 million travellers from the north towards the south shows that more effort is being made to protect travellers than to protect Africans. It's probably not by chance that out of the 5 vaccine projects, the one that has received the most money is the one aimed at travellers. The favoured traveller being first of all troops in a mission, followed by tourists because they can pay, and then businessmen because they can also pay. But north-south exchanges are increasing. We are more and more obliged to be concerned by malaria.
At the moment, the treatment of the disease is benefiting from all the media coverage. This recent awareness really seems to be accompanied by an increase in the means to fight it, connected, however, to our own anxieties.